Assalamu alaikum students. This is model paper 2025 and this is secondary chemistry, any chemistry part 2. So this is according to the reduced syllabus that was introduced in 2025. And so first we will see the multiple choice question. In this question they are asking about in 3A group of the periodic table, the ionization of gallium is higher than aluminum due to insufficient shielding of the nuclear charge in gallium by 4s electrons, 4p electrons, 3d electrons, or 3p electrons. So the correct answer is 3d electrons. Why? See, this is the electronic configuration of aluminum and gallium. And you can see very clearly that it has 3D completely filled orbital. So due to the electrons in 3D, the shielding on the 4p and 4s becomes insufficient. And that's why it has higher ionization energy as compared to aluminum. Although the general trend for ionization energy is that ionization energy decreases down the group, but here in this case there is a um, deviation from the normal trend. So the reason is the 3D orbitals, which causes decrease in the nuclear charge, decrease in shielding effect. So if the shielding effect is decreases, so the nuclear charge is increases. So the effective nuclear charge is more as compared to aluminum. So that's why the correct answer is 3D electrons. This metal is essential for bones of the teeth. So bones of the teeth, bones and the teeth, sorry. So bones and teeth both requires calcium. This is the general fact. Third MCQ says the boiling point and the viscosity of sulfuric acid is higher because of it is a strong oxidizing agent. No. It is highly volatile. No. If it was highly volatile, then the boiling point should be lower. So this statement is contradictory. It has strong hydrogen bonding. Yes, it is the correct answer. This is the correct answer. It has strong hydrogen bonding. It forms the stable sulfur oxygen bond. It doesn't mean that if the bonds are stronger and then bonding boiling point is higher. Except the giant covalent molecules, it doesn't happen. Giant covalent molecule means diamond, graphite, silicon dioxide. Okay, the coordination number of platinum in PT and thrice Cl4 is. So if we want to determine the coordination number, so we should know what is this ligand. En stands for ethylene diamine, and the structure of ethylene diamine is this. It has two amine group, and due to the two amine group, it has two groups which are electron donating, so they can donate electron pairs. So as there are three ethylene diamine, so it means they can form 6 coordinate bonds with the platinum. So this is an octahedral complex, and in octahedral complex, coordination number is 6. Or you can directly multiply 3 multiplied by 2 is 6. This metal has maximum number of unpaired electrons in 3D orbitals. So first find the atomic number is 29, it has 25, it has 27, and it has 26. So the correct answer is manganese. Why manganese? See, its atomic number is 25, so its electronic configuration is 1s2, 2s2, 2p6. 3s2, 3p6. Then 4s is filled first, so 4s2 and 3d. How much left? 10 electrons and 10 electrons, so 5 left. So there are 5 electrons in d orbitals, and we know that in d subshell there are 5 orbitals. So 5 orbitals have 5 electrons according to Hund's rule. They will be filled singly. So with same spin. So this d5 system has the maximum unpaired electron, while in rest of the cases cobalt is d7, so it has 2 paired d orbitals and 3 unpaired. Iron 2,6, so it has 1 paired d orbital where the paired electrons are there, and 4 orbitals are unpaired. Copper is 29, so for 29 electronic configuration would be 3d9 or 3d10 and 4s1. So this is a d10 system. It has no unpaired electron. So the maximum unpaired electrons are in manganese, which are 5 unpaired electrons or the 5 unpaired orbitals. The general formula of the homologous series of cycloalkane. Remember that the cycloalkane and alkenes both have the same general formula, that is CnH2n. Both has deficiency of 2 hydrogen atoms. The final product obtained when hydrogen bromide is added to the ethyne. So ethyne is this molecule which has triple bond. So what happens? When the first molecule is added, it does not follow Markovnikov's rule because both the carbon atoms are similar. So one hydrogen atom goes to one of the carbon atom while bromine on the other carbon atoms. But when the second molecule will be added, so there is a Markovnikov rule. So the negative species goes to the carbon which has less hydrogen atom. So Br comes on the same carbon atom. So geminal dihalide is obtained while hydrogen comes here. So the structure would be CH3, CH, Br2. So this is 1,1-dibromoethane. Okay. So here Markovnikov's rule applied. The sooty flame observed when benzene burns in due to any aromatic compound gives sooty flame because aromatic compounds have high percentage of carbon. So the main reason is this, and the unburned carbon forms this sooty flame. The carbonyl carbon of aldehyde, if you draw the carbon, it has carbon oxygen double bond. So there are if there is a double bond, then it must be forming 1 pi orbital between carbon and oxygen. So if it is forming 1 pi bond, so it represents that it has one unpaired electron. Oh, sorry, one unhybrid orbital. So sp2 hybridization generates 3 sp2 hybrid orbitals and 1 p orbitals remains unhybrid that form the pi bond. So the answer is sp2. Remember that whenever carbon is forming a single double bond, I mean one double bond, then it must be sp2. If all the 4 bonds are single, then that would be sp3. And if it is forming a triple bond, for example, in case of alkynes, or it is forming 2 double bonds simultaneously, for example, in case of carbon dioxide, then it is sp. This is also sp, but it is sp2. So the answer is sp2 hybridized. Lucas reagent is a mixture of, we should remember that Lucas reagent is a mixture of zinc chloride and HCl. When Grignard reagent reacts with ketone, it produces, Grignard reagent produces tertiary alcohol because in ketone, around the carbonyl, both the carbon is bonded with other carbon atoms. These are the alkyl groups, whether methyl or any other alkyl group. So we know that Grignard reagent is an organometallic. In organometallic, carbon is negative. So for example, if there is a methyl group, it attacks on the electrophilic carbon. So it already has two carbon atoms. So third carbon atom will be bonded here and it becomes OH. So the product would be tertiary. It would be the product. CH3 comes here and it becomes OH, while this double bond changes to single bond. So this is the tertiary alcohol. Remember that whenever Grignard reagent reacts with ketone, it produces tertiary alcohol, and when it reacts with any aldehyde, it forms secondary alcohol, and when it reacts with formaldehyde, that is methanol, then it forms primary alcohol. Okay, so the answer for this MCQs is tertiary alcohol. An example of transport protein. Transport protein are responsible for transferring or transporting certain molecules from one part of the body to another part through blood. So the transport protein is hemoglobin that transport oxygen from lungs to rest of the body tissues, rest of the body organs. So this answer is hemoglobin. The compound among the following is known as oxime. Oximes are the products when hydroxylamine reacts with carbonyl compounds, aldehyde or ketones. And during this reaction, what happens in the carbonyl compound? This hydrogen forms water with the carbonyl oxygen, and nitrogen forms the double bond. So there would be carbon nitrogen double bond. Carbon nitrogen double bond is here. Carbon nitrogen double bond is here. Carbon nitrogen double bond is here. So we can, it cannot be the answer. But with the nitrogen, there would be OH. So OH is only here. So the correct answer is this. This is an oxime. And now the anti-malaria drug. So the we should remember that chloroquine is an anti-malarial drug. But the most prevailing drug nowadays is artemether, but it is not the part of our syllabus. So here the correct answer is chloroquine. Ozone is destroyed by sulfur dioxide, no. Carbon dioxide, no. Chlorofluorocarbon, yes. This is the main cause that destroy ozone layer. Hydrofluorocarbon, actually hydrofluorocarbons are developed to replace CFCs. So this is not damaging ozone layer. It damages the ozone layer. Now the IUPAC name of the formic acid has only one carbon atom. So this is the methanoic acid, only one carbon atom is there. So meth is the suffix for one carbon atom. The pH of acid rain is between 7 to 8, between 6 to 7. This is if it is going to 8, this is alkaline, not the acid. Between 6 to 7, this is the normal range of the rain. And below 5, yes, it could be the correct answer, because this is also alkaline. This is the normal rain pH. and this is also alkaline. So the correct answer is below 5. Sometime acid rain may have a pH of 2. Anyway, it must be below 5. So that was the question number 1. In the next video, we will see the other questions as well. Allah Hafiz.